So now that we've seen the area under a curve, what we're going to start doing is taking that area and revolving it around a line and then figuring out the volume. So as far as steps go, we're going to really do two steps here. We're going to start with an area, and we're going to do this exactly the same way we've done before. And then we're going to rotate about some sort of line. So your picture that you're thinking, I'm going to have some sort of area. I don't know what it's going to look like. Maybe it looks like this. And then we're going to revolve that around some line. So maybe the line is, let's say, x equals -1, so that we get a different shape. So you want to kind of imagine this area is coming out of your page through the back of your page and creating a 3D shape. So in this one, it looks like a donut because it has a hole in the middle. So I'm going to do two examples of discs. Then in the next one, we'll see washers. So the first example, my area is going to be f of x equals 2, the x-axis, x equals 0, x equals 10, and I want to revolve this around the x-axis. So you always want to start with, what does the area actually look like? So we're going to figure out what's the area bounded by f of x equals 2, so that's just a horizontal line. The x-axis, I already have that. X equals 0, that's the same as the y-axis, and then x equals 10. So the area bounded by all of that is this rectangle. So there's my area. Next, what I want to do is now imagine rotating this about the x-axis. So here's your x-axis. I'm going to take this, mirror it across the x-axis, and then connect all the edges. So here's my picture. It's just a can that's been put on its side. And the way we're going to figure out the volume is we're going to take a slice out of this. So take a slice out of this can and imagine pulling it out. So imagine pulling that out of the can. We're going to figure out the volume of the slice, then use an integral to add up all the volumes. So this slice looks like a circle with just a little bit of depth, right? So the area is going to be pi r squared times that little bit of depth. We need to figure out what's the radius and also what's the depth. Well, when I took the slice, I hit the x-axis, so my depth is delta x. If I would have sliced it and hit the y-axis, it would be delta y. As far as the radius goes, if you go back up here to this picture, the radius is being measured from the x-axis up to that top edge, and it's the same for any slice that I would have taken, and it was always 2. So I have pi times 2 squared delta x. There's the volume of one slice, so we're going to use that to get the volume of the entire shape that we have. So we're going to integrate 4 pi dx. The 4 came from the 2 squared. But now we got to decide, where do we start adding up slices? And that was at x equals 0. Going from left to right, we stop adding up slices when x was 10. Antiderivative of 4 pi is 4 pi x. Remember, pi is not a variable, so I'm not going to add 1 to the exponent or anything like that. So 4 pi x from 0 to 10, which gives me 40 pi. So the volume of this is going to be 40 pi. Do another example. This time my area is y equals the square root of x, the x-axis, x equals 2, and x equals 4. And we're going to revolve this around the x-axis. Okay. So again, first thing, let's draw our area. So square root of x is this curve. The x-axis we already have, x equals 2 and x equals 4. So there is our area. We are going to rotate this about the x-axis, so right here. So imagine reflecting it and then connecting all the edges. So kind of hard to see, but I'll draw it over here to the side, hopefully a little bit better. I rotated it because I think it makes more sense to look at it this way, but hopefully you can see it's a bowl, a solid bowl that's been put on its side. So imagine kind of flipping that 90 degrees. So to figure out the volume, I'm going to start by taking a slice and imagine, what does a slice look like? Well, it's again a disc with a little bit of depth. So my volume is going to be the circle times that little bit of depth. And I already know the depth is going to be delta x because when I sliced it, I hit the x-axis. So it's going to be pi r squared delta x. The question is, what is the radius? So the radius is going from the center line up, and it's different for every slice. Like on the last example, it was always 2, but for this one, it's different depending on where we slice. But it's always given by this curve, y equals the square root of x. So then I'm going to have the square root of x squared. So my overall volume, when you do the square root of x and square it, you're just left with x. So I'll have pi x dx. As far as bounds go, move from left to right. Where do you start adding up slices? That's at x equals 2. And where do you stop? That would be x equals 4. So my integral is going to be from 2 to 4 of pi x. Antiderivative, you're going to add 1 and divide by that new power. So pi over 2x squared from 2 to 4, which gave me 6 pi.